this name is wrong here, 20 kilobytes. It's like 80 kilobytes of backing arena storage, for example. If we build that and then run it, we can move around and whatnot. Like that worked fine, but if I happen to run down on this reproduction case, we run out of memory, and that's because the table keeps resizing. And so I basically just kept bumping the memory here to some new value, higher value, some higher value, some higher value, and I was constantly surprised. We have multiple things we can do. So the first thing that we can do just to save memory is to think a little bit harder about what the size of the table entry should be. For the vector, what we could do is actually store tile indices. And an 8-bit index, a U8, is probably too small. It's probably going to be more than 255 tiles. So the next up would be 16-bit, and that's probably plenty, I would imagine, a 16-bit tile. So we can quarter the size of the key. And then for the value, for the cost, I think we can, I don't know if we'd be able to get away with the U8 for that. So then we could also go to 16-bit, a U16 for that, and we would quarter that as well. And so we would save 6 plus 6 is 12 out of 20. We'd be left with like 8 bytes. So we'd have a more than 50% size reduction. That would allow us to not use so much arena memory. The other thing that I want to do in general is just undo, so probably stash or commit these changes here, the diff changes here. And I just want to look at the size of the allocated dictionaries when using the temporary allocator. And I'll note that size down and I'll compare that to the data structure sizes and the kind of memory in use and whatnot when I'm using my allocator. Git log, check that out now. Then we'll build and we'll run. And there should be no issue at all with this. And initialize, we just take these guys and paste them in. Okay, so what this is going to do is reproduce the situation that was causing us to run out of memory previously. Oh, min heap, no space left in heap. Okay, so this is interesting. So we actually, given sufficient distance between the player and the enemy, we actually run out of heap space. This is a latent defect. Maybe I should have dynamic heap as well, but for now, the way we're going to fix this for now is just doubling the size of the heap. Right now, what we want to do is basically come down. We want to break somewhere around here, or before the dinit. So we want to break on dinit and then inspect the data structures. Cost so far came from this sort of stuff. I've never seen it. This is a lambda? Like a one-line lambda? Map.jai in 371. And so we ran and we broke. P cost so far. Oh, not data, count. Entries count is 256. Allocated is 256. That's already 5K. Came from is exactly the same. It basically tracks cost so far as well, like around the same size. Break the game by going down like this, and I say continue, and we break again. And I'm assuming extended cost so far. Indeed, we have. Allocated is 512, and then again we print came from also 512. Every time we double this, what we're actually doing is a realloc with a free, right? Or like, it's not even a realloc really, because realloc wasn't getting called, or resize wasn't getting called. It's basically just new array. But in the temp allocator, we don't actually free anything. This is how we quickly exhaust the amount of memory available in the backing arena. The thing that I'm looking for is free supported on the temp storage. Of course, it's supported because we're freeing the new array in the expand procedure in hash table. But what I mean by supported is, does it do anything? Does it actually free anything, or is it working kind of similar to this arena? It's more of a curiosity. I don't actually need an answer. Well, maybe not super interesting for anyone watching this, so I can get into the deeper details later. For now, let's do a little surgery to change the number of bytes used for an entry. Let's do that. 65,000 is plenty for a tile ID, so we definitely don't need 64 bits. We can get away with 16 bits for these indices. Frontier, we'll just keep this as a math vector 2f for now. I can change that to a U16 later. For these tables, 2 U16s, map of least cost so far to get to some tile index destination. This will be a U16. And this will also be a U16. We'll shave a lot of size off there. I want 512 elements, right? So let's do some quick math here. We're gonna have 4 for the hash, plus 2 for the U16, plus another 2 for the U16, times 512 is going to be, that's going to be 4 kilobytes, okay, instead of, yeah, so that it was 10 kilobytes, right, 10. So we're going to go from 10 kilobytes to 4 kilobytes. We no longer need these hash functions, and we don't need the compare function. Now for from, what we need to do, there's going to be all kinds of nasty casts in here. World file to world index. In a previous stream, I didn't have this assert here, and I realized I was passing in a view over the backing buffer. We need to actually assert that we have enough space in the backing buffer. Okay, we convert the tile. Now we do all this operation on tile, and now here we need to convert back. Oh yeah, so I was also thinking of making the cost for heaps a generic type. So that way I could downsize this drastically. I could save 75% on your car insurance by switching to U16s. Okay, we'll get rid of that. So this needs to be a U16. That's the frontier. Cast U16. Right. Do we just barf or do we run? We run. This is great. 8 bytes times 512, basically 4096. Right. So like 2 to the 4 times 2 to the 9, 4096. So that's 4K. Yeah, we got a pretty big size savings there, over 50% size savings on both of these. If we were to go back into game, have 40 kilobytes, like will that do? 40 kilobytes appears to do, but what I need to do, like the map is probably going to be much bigger than this. This is just a test map. I'll need to actually do some math to figure out kind of what an acceptable like safe size is. If I'm a player, not a developer playing this game, right, and I try and something's running behind the scenes and we run out of memory to do something and the game would otherwise crash or complain like it is doing now with like seg faults and whatever, what I would rather have happen without me even knowing is the algorithm that's trying to run, that's running out of resources, will detect that it doesn't have enough resources to, in this case, find the correct path. And so I'd like to just have fallback to like random movement or I don't know, even like a really naive Euclidean, like a very quick, cheap Euclidean point to point. Like I establish a vector from point to point, and then just try and follow that vector, take one step toward the vector. Even if it's a wall, you just bump into the wall and the character just looks like it gets stuck or whatever, like some kind of graceful fallback mechanism. But unfortunately, I think what's happening, right, if we go look at the code here, as you'll notice here, table ensure space doesn't make sure expand can actually work. Expand doesn't return anything either. It's just like, yo. And so when my allocator runs out of space, it returns a null pointer. I think that's what we're supposed to do by the returns null if the program is out of memory, so that the request cannot be accommodated. I return null, but so I'm following the API, but I have no way to actually recover from that because I am in some other caller code that just fails because it doesn't check the return address. It just tries to dereference it or something. Right, we get a seg fault. There's no way for me to protect against out of memory for these guys. I could be overthinking it. Maybe, maybe I should just go to the heap or whatever. I want to add a bunch of enemies and just see what happens. They're all going to come swarm me. Let's go into the game state. Here we go. Enemies, you are going to be an array of enemies. So you see what I'm doing here? Like we're going to have some, for example, we can have some enemies, some backing storage for 100 enemies or entities. I call this just call it entities data or something. We'll keep it as enemies for now. And then I'm going to have a view over this. So when we start, we're going to have 100 elements in here, default initialized. But when we access the enemies, we access it through the view. And the view initially is going to, I need to set it in the initialize. The view will look at this guy here. So it'll point to its backing data, but the count will be 0. I don't know anything about entity component systems. That topic comes to mind. Maybe there's going to be a much more elegant way to do it. Not maybe, probably there's a much more elegant way to do this. I also needed a way to share assets across enemies. So yeah, there's a lot of optimizations I need to make. For example, right now I load in an asset per entity, but essentially you'd probably want an entity to have like an asset ID, I guess. You'd want like an asset table. And then you'd want entities to have asset IDs, IDs into the table. Because right now, each entity is just going to duplicate the same asset. We can set up the optimization later. Num enemies is going to be, we'll do 3 for now. GS enemies data is GS enemy data.data. So we have 3 enemies, 0, 1, and 2. Enemy is GS enemies pointer to it. So we'll get enemy. It already has a pointer, so we need to pass that in. We get the pointer in GS. Enemies.count plus equals 1. Okay, for enemies, gs.enemies. For gs enemies, we set the proposed facing direction. Then we say, are we found? And then we take next step toward. I do set properties on this, so I think I need to go by pointer to this. If the destination is not found, then we do random movement, and we do random movement on it.pause. It facing it.move cooldown left is this, then get precise DT, or it.move cooldown last per count, GS per frequency. Maybe bring that into top scope. It might already be in top scope. I think it is. Entity.jai. Yeah, as using. So it already is, but for some reason I qualify it fully. That's funny. The entity render thing doesn't quite work though. So we'll just comment this out for now. This is can move to check the position against all the entities in the game. For BF enemies, if pause is it.b.pause, since I like to say that, and false. That actually builds. We're not going to be able to see the enemies. I kind of want to run it. Does it immediately? Yeah, it immediately crashes. Yeah. The tenth index is 0, but the array has dimension 0, so no index is valid. That is correct. I guess we don't do this. I guess we do this. And then this will just be in... Okay, now I can't see them, but I'm hitting them already. Or I'm hitting one at least. Let's draw them. For, yes, enemies. Guess we will need to pass by pointer. No, we don't need to consume by pointer. We'll just take a pointer to it. Up, and it dies. Missing 2 index and came from while rebuilding path. But now it works. So, all right. So that's good to know. I'll have to address that. But now we have, okay, there's 3 of them. Yeah, the pathfinding is really funny. So we have some latent, we have multiple enemies and we have latent defects and stuff. Search and failed. Missing 2 index and came from while rebuilding path. When would we never place 2 index in there? On initialize, print all initial positions of enemies. That's what we need to do. That will help us debug in the future. There we go, reproduced it. But it's pretty clear what's going on here, right? When an enemy overlaps the player, they can't find us because we have an early exit right here. If me is equal to me, basically, if I am equal to I am equal to me, then we say destination is reached, but we break. And that's usually okay because we usually at least loop through the neighbors once, and then we assume that the player is next to the other guy, like one tile is next to their tile. And so from and to are separate tiles, but they're adjacent. And so we'll come in here and we will add. And then so that way, when we come in here, came from, we know that the 2 index is going to exist in there. But if we overlap each other like this, like the player here and the enemy here, then that's going to be a bug. That's going to be in this guy right here, assign entity positions, right? There's a bug in here. And we have this to do right here. Debug issue where multiple entities get the same location. I call this thing array unordered, remove by value. This is what I assume is supposed to be helping us. It's not behaving the way that I'm anticipating. So let's check on our side whether this is actually affecting the count. Spawn lux. That's still 28 because we haven't called array unordered remove by value. Just go next. Okay, so but like the count is still 28. So okay, this is the issue right here. Okay, whatever's going on here with the array pointer count thingy, like this looks exactly like what I want. So I guess I'd call remove by index. And that actually makes a lot more sense. I don't know why I'm removing by value because I am passing an index. I guess we'll come in here again. P spawn lock should be 27. It's 27. And then as we go through here, 26. All right, so I think that problem is solved. Everything should be good. Oh, this time they actually surrounded me. And now I'm soft locked. Okay. I would get them in a situation maybe here, like, yeah, where they won't like close in on me. I have to figure out why that is. All right. Thanks again for tuning in, and I'll see you next time.